Welcome to the 13th lecture in Riparian Function and Management. Our previous lesson covered some key considerations in understanding the basis for riparian management, in which we discussed intensity of riparian management, riparian function as a cornerstone, maintaining equilibrium, identifying, addressing, and removing hindrances, natural regeneration, and artificial revegetation. Today we will apply that understanding as we learn about general riparian management guidelines for different land use types. Riparian management practices and techniques are determined in large part by the surrounding land use. Land that is in agricultural production usually has different riparian issues than urban or recreational land. Likewise, land that is used for timber production has different issues than land that is used for row crops or for livestock grazing. Land in the eastern half of Texas tends to include mostly forest and croplands, and land in the western portion is mostly used for livestock grazing. Approximately 27 million acres of Texas land is used for crop production. A large portion of the cropland in Texas is located in the high plains, where creeks and riparian areas are few and far between. However, cropland is scattered across all parts of Texas, and much of it is located in proximity to creeks and rivers. The potential impacts of farming on adjacent riparian areas are numerous. Plowing and planting too close to a creek or river bank is a serious problem that can cause significant riparian damage. The removal of deep-rooted perennial vegetation and the conversion of cropland will greatly accelerate the risk of severe erosion and bank failure. A common-sense solution for this problem is the establishment of non-cropped, permanent buffers composed of appropriate native, deep-rooted vegetation between the edge of cropland fields and the banks. Here, farming is taking far too close to this creek. A filter strip of dense perennial grass is needed at the edge of this cropland field to slow down runoff, trap sediment, and reduce erosion. Switchgrass and Indian grass are good choices for native grass filter strips in many locations. Filter strips may need to be wide enough to achieve the goal of dissipating runoff energy. The proper width of non-cropped buffers will vary from place to place. Larger creeks will need wider buffers than smaller creeks. The safest buffer would include the entire 100-year floodplain, which would ensure that very little cropland would be subject to flooding and erosion in a very large event. Another consideration is to leave a significant buffer along the edge of a high bank. These high banks are often unstable, especially on the outer side bends. Leaving a buffer of natural vegetation equal to 3 to 5 times the height of the vertical bank will help to accommodate the development of vegetation as the bank erodes. Another consideration is to plant a dense herbaceous buffer between the edge of the cropland field and the beginning of the slope that leads to the riparian areas. The purpose of this grass strip is not only to stabilize the soil, but also to help trap sediment coming off the cropland field and to reduce concentrated flow into the riparian area. The most commonly used grasses for this include switchgrass, Indian grass, and eastern gamma grass, although species will vary by region. Farmers should resist their inherent urge to manicure, mow, or spray weeds in this buffer area after establishment. A riparian buffer established between cropland fields and the riparian area will reduce the movement of sediment, nutrients, and pesticides into the creek. Incentives are available to farmers to plan and establish buffers and filter strips. Farming methods on upland fields can also have an impact on adjacent riparian areas. Farming practices that slow down the movement of water and reduce sediment and nutrient-laden runoff into the creek will help maintain the integrity of riparian areas. These practices include terraces, contour farming, cover crops, crop rotations using high residue crops, conservation tillage, residue management, contour buffer strips, and filter strips. In addition, the proper application of pesticides and fertilizers will help reduce or eliminate the movement of potential contaminants into a creek. In addition to traditional commodity crops, cropland areas are also commonly used for grazing. Where crops or crop residue are grazed by livestock, there are other riparian considerations that must be addressed. Grazing management will be discussed later in this course. Approximately 11 million acres of Texas land is classified as pasture land. Pasture land is defined as perennial grasses under intensive management grown for grazing and/or hay production. Pasture land almost always involves a monoculture of exotic grasses, but occasionally native grasses are utilized. Pasture land is not to be confused with rangeland, even though both are used for grazing. Rangeland riparian considerations will be discussed later in this lesson. Common pastureland grasses in Texas include coastal Bermuda grass and other hybrids, Bahia grass, various exotic blue stems, buffle grass, Klein grass, and Vilman love grass. Management of pasture land usually involves the regular application of fertilizers and the control of weeds and woody plants. Pastureland is often established as the best and deepest soil in a farm or ranch, and therefore is commonly located near creek, riparian, and bottomland settings. The potential risk of having pastureland immediately adjacent to riparian areas is the same danger of erosion and bank failure. Most pastureland grasses do not have the same stabilizing ability as native riparian plant communities. Riparian management in and near pasturelands should include the use of buffers of native vegetation adjacent to the creek. Routine weed and brush control should not be carried out in or immediately adjacent to the riparian area. Another potential risk associated with pastureland is the presence of livestock concentrations in the creek area. In most cases, livestock will drink water from the adjacent creeks and seek shade in the riparian area. If livestock concentrations persist without adequate rest and recovery periods, the damage to the riparian plant communities will be substantial from long term. And in this case, management should include the development of alternate water supplies away from the riparian area. Water can be pumped with solar energy from the creeks to troughs. Where livestock continue to loaf in the riparian area, fencing may have to be established to exclude or manage grazing of animals. Pasture land use for hay production rather than grazed forage will eliminate potential grazing problems in nearby riparian areas. For additional information, refer to the section on grazing management in this manual. Approximately 97 million acres of Texas land is classified as rangeland. Rangeland is by far the most predominant type of land in Texas, comprising nearly 60% of the land area of Texas. Rangeland is defined as land that supports predominantly native vegetation and is normally managed extensively rather than intensively. Rangeland includes many types of land, such as grasslands, shrublands, deserts, savannas, woodlands, and some wetlands. Rangeland is commonly used for the production of grazing animals, but not all rangeland is grazed. Rangelands are also commonly used for the production of deer and exotic wild hoofstock. The majority of creeks and rivers in Texas originate and run through rangelands. When proper management is applied, ranchers can benefit from riparian forage as well as maintain good riparian conditions. Without good management, livestock tend to concentrate in riparian areas, causing damage to riparian vegetation. The importance of rangeland management on Texas riparian areas cannot be overemphasized. Historically, since the late 1800s, rangeland has been the basis of the vast Texas livestock industry. In those early days, creeks and rivers provided the only watering locations for livestock, and many riparian areas were very heavily grazed for decades. Even after the development of countless earthen ponds and the drilling of water wells to provide livestock water, creeks and rivers have continued to provide important sources of water on many ranches. In addition to water, riparian areas also provide large amounts of forage and shade for summertime temperature regulation. Because of the presence of water, shade, and forage, riparian areas are often subjected to unintentional, concentrated, and disproportional livestock grazing and loafing. Without intentional management, this tendency for livestock to congregate in riparian areas can have severe and detrimental effects on riparian vegetation. In addition to impacts on the vegetation, livestock concentrations can cause accelerated bank failure, and trails can lead to secondary erosion problems. Livestock grazing affects many different kinds of riparian vegetation, including grasses, sedges, forbs, and woody plants. Many desirable riparian plants are also very good livestock forage plants. Careful management and preferential treatment of riparian areas is essential to maintaining or restoring functional riparian conditions on rangeland that is used for livestock grazing. Grazing management will be the subject of an upcoming lecture. Approximately 7.5 million acres of Texas is commercial forest land that lies exclusively in East Texas. Forest land is dominated by a dense canopy of trees, including pine and/or various hardwood species. The distinction between wooded rangeland and forest land is not always easy to make. Some areas traditionally regarded as rangeland have a dense canopy of trees. This is especially true in the cross timbers and the post oak savanna, and is also true in many heavily wooded riparian corridors in the central part of the state. Forest land in Texas is mostly restricted to the East Texas timberlands and the piney wood ecological regions. Management of riparian areas in forest land primarily involves timber harvest practices. The size of the equipment used in timber harvest and the intensity of disturbances involved in transporting logs can lead to extreme disruption of the soil surface and associated vegetation. Furthermore, the subsequent preparation of seed beds to plant the next crop of trees adds even more disturbance. For these reasons, it has become standard practices for timber harvesting activities to include streamside management zones, or SMZs. These streamside management zones are similar in purpose to riparian buffers. Their intent is to maintain undisturbed or lightly disturbed areas of native trees and shrubs adjacent to the creeks and the rivers. Streamside management zones are often planned at least 50 feet away from the top of the bank, but width should vary according to the size of the creek and the length of the side slopes. When private landowners sell timber, it is recommended to have a written contract with stipulations to protect riparian areas and to utilize the services of the forestry professionals. Typical streamside management zone guidelines often include minimizing stream crossings, building no roads in the SMZ other than necessary crossings, using temporary bridgements to skid logs where possible, to avoid traffic in wet weather to minimize rutting, to keep skidders away from banks so not to skid logs across the creek channel, to use cable and chokers to skid logs, and to limit harvests to individual high-value trees. In addition to timber harvest considerations, cattle grazing can also affect riparian areas in this forest land. In this part of Texas, cattle often graze upland pasturelands in their fields during the growing season and are allowed to graze the woods in the winter. Most creeks in urban areas have been altered in one way or another. Removal or alteration of natural riparian vegetation is common. The increased runoff in urban areas combined with riparian alteration creates a greater risk of erosion during high-flow events. Retaining or restoring a buffer of natural vegetation will help maintain a degree of riparian function. Land within urban settings or developing areas creates one of the greatest challenges to riparian management for several reasons. The land area that drains into urban creeks is often highly altered by a large proportion of impervious surfaces, a high runoff, water-shedding landscape. These impervious surfaces create rapid and high-volume runoff, even with small rainfall events. The greater the volume or runoff entering tributaries and creeks can wreak havoc on channels, causing abnormal and severe erosion, bank failure, downcutting, and other problems. In addition to the flashy nature of urban creeks, urban development often encroaches into the floodplain, restricting the ability of the creek to naturally meander. Encroachment of development into the floodplain results in the alteration of floodplain topography and vegetation. The net result of these alterations is a reduced capacity for the floodplain to function as it should. During the construction phase of development, abnormal amounts of sediment, as well as runoff, may enter creeks. The use of temporary sediment fences may reduce the delivery of sediments into the creek, but often fail to control sediment adequately during large runoff events. After construction is complete and pavement is installed, sediment load is often decreased while runoff is greatly increased. This combination leads to severe erosion of banks and the bottom of the channel, since the hungry water, free of sediment, has greater energy with which to cause erosion. In an effort to deal with erosion and increased discharge, cities often resort to alterations of the stream channel and floodplain. Where erosion is severe, hard or soft engineering solutions are often implemented. Vegetation and large wood is often removed to allow floodwaters to move through the channel faster in an effort to reduce the magnitude of flooding. However, by removing the roughness from the stream or riparian area, the energy of floodwater is increased, causing an increase in bank and channel erosion. Furthermore, when floodwater moves more rapidly through the urban areas, flooding problems farther downstream are exacerbated. Municipalities or subdivisions that desire to minimize damage to creeks and help maintain semi-functional riparian conditions can plan developments to retard runoff and retain wide, well-vegetated riparian areas. The reduction of impervious surfaces, rainwater harvesting, detention storage for stormwater, water gardens, green belts, and other practices are used in some developments to help maintain some natural riparian function. City engineering departments should be taught about the basic processes of riparian function, and especially the role of vegetation and large wood in creeks and riparian areas. Land that is intensely used for recreational purposes is also vulnerable to riparian degradation. Creek and river areas subject to heavy recreational use can be some of the most abused and degraded riparian areas in the state. Continual long-term foot traffic often reduces dense riparian vegetation and creates compacted bare ground. Public and private parks and recreational areas used for hiking, biking, swimming, camping, fishing, birding, and horseback riding can be degraded by sustained use. However, those impacts can be minimized by management. Shown here is a good example of riparian recreational management at the Devils River State Natural Area, managed by Texas Parks and Wildlife Department. Restricting access to small mowed areas and rotating those areas will help maintain good vegetation in heavily used recreational area. The following management practices can be used in recreational areas to reduce negative impacts. Eliminate or restrict vehicle traffic in riparian areas. Trails should not be aggressively devegetated. Trails should not be immediately adjacent or parallel to creeks. Meander trails back and forth across the floodplain. Place main trails on higher ground with periodic access trails down to a stream. Locate periodic access trails on inside bends with less stream energy. Separate heavy use areas with buffers of thick natural vegetation. Choose less vulnerable areas for heavy use, such as inside bends. Rotate heavy use areas to allow for periods of recovery. Limit mowing and increase the interval between mowing to encourage vegetation. Rotate mowed areas to help manage human activity. Rotate heavy use access points to allow adequate time for vegetation to recover. Do not remove large logs and dead fallen trees in creeks, along banks, or in the floodplain, and provide educational material to describe the reasons why these practices are carried out. Today's lesson introduced general riparian management guidelines for land use types. These land use types included cropland, pastureland, rangeland, forest land, urban land, and recreational land.